before you watch it all together, what we want to do is plug this y in here, plug in the second derivative of y, try and make it all work, and solve for k. You can try it on your own. Go ahead. It's not going to be easy, but give it a try. So first things first, since I know I'm going to have to plug in the second derivative of y, I'm going to go ahead and find the second derivative of y. So y prime is going to be the derivative of that. Derivative of e to the 2x is 2e to the 2x. We've talked about that lots of times before. So likewise, I'm going to have over here a negative 3k e to the negative 3x. So then for that second derivative, I'm going to have 4e to the 2x plus 9k e to the negative 3x. Now that that's done, I'm going to go ahead and erase this, but that is what we're going to plug in for y double prime. I want that whole differential equation, this whole thing, to line up with a particular value of y given a particular value of k. So the next thing I'm going to do is plug in y here, plug in y double prime there, and then try and solve. So let's go ahead and do that. I'm going to have 4 times y. So I'll just start out with parentheses, 4y, and I'm going to box this, just so we know that's our initial given condition. We can separate it out. 4e to the 2x plus k e to the negative 3x. Oh, not equal, sorry. Minus our second derivative of y. We're going to set this equal to 10e to the negative 3x. Let's just drop down a line. I can distribute that 4 and I can plug in my y double prime. So this 4e to the 2x and that 4e to the 2x can cancel. I have 4k e to the negative 3x minus 9k e to the negative 3x. So let's just rewrite first simply 4k e to the negative 3x minus 9k e to the negative 3x. Those e to the negative 3x's obviously are going to kind of get rid of each other. I have 4k minus 9k, which of course is, so let's rewrite over here 4k e to the negative 3x minus 9k e to the 3x. When I subtract those, I'm going to have negative 5k e to the negative 3x, and that's going to be equal to 10 e to the negative 3x. Dividing both sides by negative e to the 3x, they'll cancel. I have a negative 5k equals 10. Dividing both sides by negative 5 leaves me with k equals negative 2. So now we're good. If I plug in negative 2 here for y, in y, I would have y equals e to the 2x minus 2e to the negative 3x. And that is a solution for this differential equation, meaning that if I plug this in for y, it's true. And we already proved that that's the case, because I said, okay, well, let's just take this equation. Let's just say it's true. We're going to do that by using it. For y here and y double prime here, I'm going to plug in this as y and its second derivative for y double prime. I'm saying that this y is a solution for this differential equation because it makes this differential equation valid. So I do that, I go through, I got k as negative 2, saying that that particular value of k makes this work. Not just any old value of k, it's got to be negative 2. You could say, well, are there other values of k? And the answer is no. It's only this one value of k. If there were other values of k, I would have gotten it from solving this equation. If that's not really sitting super well, if you're still not sure, or you think, well, maybe there could be other solutions for k, then shoot me an email and we can talk about it some more. That's the end of this example. Let's move on to example number 5, which is the last example for 6.4. You guessed correctly. Example number 5 is an AP question. It is from the multiple choice section, and it is no calculator. So far, I haven't really needed the calculator at all, but you could get benefit from a calculator from this in terms of pretty basic stuff like 10 minus 5, and things that aren't too complicated in comparison to the rest of the calculus we're doing. I don't think that anyone studies differential equations and says, "Whew, man, 10 divided by 5. What am I going to do?" If arithmetic is a struggle for you, then I relate to you. Dividing and like big complicated things, we all know in class that sometimes I'm a little slow with the arithmetic, but 10 divided by 5 is certainly something that pretty much all of us can do without a calculator. So in the calculator questions, you might have more complicated coefficients, you might have more complicated resolutions for solving for k. Maybe you'd have to do some square roots or some decimals or irrational numbers like pi. If you had like a trig involved in a differential equation, so it could certainly get more complicated. But this is still this exact same process you're gonna follow. It might just be slightly more complicated in terms of the calculator work you got to do, the arithmetic you got to do with the trig maybe, or even exponential and logarithmic functions. It could be things that you have to do in a differential equation. So in example number 5, we're going to talk about which of the following solutions that are solutions to the differential equation y double prime minus 6y prime plus 8y equals 0. This is the differential equation that we want to find a solution to. It gives us 3 options as potential solutions. We have 1, which is y equals 2 times the sine of 4x. We have number 2, which is y equals 3e to the 2x. And we have number 3, which is y equals c times e to the 4x, where c is a constant. Now, to find the solution, we are going to test each of them one by one and see if they are solutions to the differential equation. I'm going to erase these now. I'm going to box this. So make sure that you have these written down so that you can look back at them as we're working through. I really miss my big whiteboard at school. And I'm even more jealous now than ever before of the teachers that have the full wall whiteboards. But you know, not all of our teachers are going to have whiteboards on the wall at their house already. Call me a nerd, I guess. All right, so number 1, the derivative of y is going to be 8 times the cosine of 4x. That means that y double prime, the second derivative, is going to be negative 32 times the sine of 4x. That's just some pretty basic chain rule. We should all be able to do that by now. I'm not going to focus on that because that's something that we covered months ago in probably October, maybe November. And when we're doing differential equations, we're going to worry about the differential equation part. If you're not sure about how I got those derivatives, then please feel free to email me. We can talk about it during my office hours, or I could even post a video re-explaining some of the older stuff. I know it has been a while since we've really done the chain rule very much. So if we want to review, we totally can. No problem. All right, plugging into my differential equation, I have y double prime, which is negative 32 times the sine of 4x minus 6 times the derivative of y, which is 8 cosine of 4x plus 8 times y, which is 2 times the sine of 4x. And the nice part about this problem is that it just needs to be equal to 0. And we can tell relatively easily, usually, if something's going to be equal to 0 or not, especially on a multiple choice problem. If a free response version of this question might say determine if 1, 2, and 3 are solutions to the differential equation, blah, blah, blah. If not, explain why. If that was the case, then we would explain why here, that it's a reason for it not being a solution to the differential equation. By saying, okay, well, I have a sine here, I'm subtracting cosine, and I'm adding sine again. This is a negative sign. So if I had this and that, I mean, this is going to be 16 16 times the sine of 4x, and this is going to be negative 32 times the sine of 4x. So clearly I'm going to end up with negative 16 times the sine of 4x. However, that's not going to cancel, right? I still have a value there. What's left is a negative cosine, right? A negative 48 cosine. And negative 16 sine of 4x minus 48 cosine 4x doesn't cancel out for every value of x. Maybe for a particular value of x, not for every value of x. So this is not a solution. Not a solution to the differential equation. Let's try number 2.